Hello everybody, this is Ali Magdi introducing my PhD thesis entitled In Extending the Morphological Capabilities of Architectural Programmable Schemes Using Bio-Inspired Methodologies. The research problem will introduce three main issues or sequential issues. The first one is how to use a new adaptive techniques for a facade design using a kinetic motions or a different morphological capabilities for a building schemes, but usually building schemes utilizing technological sensors, high electrical involvement, which are not durable and efficient enough because of its high cost, maintenance, and running power. Also, while using natural self-assembly material, these materials have limited type of morphological interactions. Also, they have limited types of motions, which lead the material to lose its efficient durability and function. Also, while using these programmable matters that exposed to different environment with different conditions, with level of humidity and temperature differs from location to another, and these factors directly affecting the material actuation and controlling the process. In the first part of the research, there will be a classification to identify the selected material to be studied and tested, and also the external stimuli that will affect the material during the research and the experimental methods and experimental phases. Also the type of movement and motion, the type of controlling and actuation, and also the time that will the material respond and the scale of the material. Then the research will concern to identify the programmable materials with the different morphologies and actuations types. Then the research will identify the material class, the material type, global kinematic motion, actuation, and control type, and also what is the building scale that the research will concern on. In the second part, the research will concern the biomimicry process, focus on the hygroscopic material scope, where the materials swell and shrink under different level of humidity that have been affected from the external environment and stimuli. The second biomimicry process will concentrate onto actuation process scope to learn from Turney Devil and Orne Lizard's skins the adaptation process while absorbing the maximum level of humidity and moisture from the environment and how they can transfer it through their skin. And then the research will implement these inputs and this database into an experimental phase through testing material behavior and motion by using different materials, laminated materials, and also under different humidity and temperature levels. And based on the experimental phase and the observations, the research will conclude a morphological matrix of the material morphological capabilities. For instance, if we took in consideration the hygromorphic materials parameters, like material type, artificial, wood, cut, orientation, lamination, perforation, and so on. So how these types and how these parameters can affect the material to make a specific morphology and motion, like twirling, rolling, rotating, bending, twisting, and so on. So based on these parameters and these morphological capabilities, we can conclude for each morphology and for each deformation the parameters that affect this specific transformation. So based on it, we can conclude in the research a morphological matrix for those the transformation and deformation based on a specific parameters of the material utilized in the research. From this point, we can conclude a cumulative programmable composite. with the different layers and different parameters to produce a specific morphology that adapt with the external environmental factors. For a verification process, a prototype of designed programmable material unit will be fabricated using 3D printing, 3 CNC milling machines, and other digital equipment to produce a real scale unit to be tested under different condition or a specific condition for a skin or an architectural skin at the end of the research. Computational and digital scripting and programming will be introduced in this part of the research. Also, to make the programmable skin workflow more parametric, the actuator or the material parameters will be connected to the final morphological type and transformation. So based on the inputs of the parameters or merging between multiple parameters, the script will conclude a specific morphology based on these inputs, and so on. And then the simulation will be involved also to know how much the morphology or this morphology will be efficient enough for the building and human comfort inside the spaces. Thank you.